guys, welcome to Athena Tutorials. This is Nagashri Bharadwaj. Today let's solve the question number 4 of exercise 11.2. Let's look into the question. The diagonal of a quadrilateral shaped field is 24 meter and the perpendiculars dropped on it from the remaining two opposite vertices are 8 meter and 13 meter. Find the area of the field. Here they have given that there is a field which is of shape quadrilateral. So this is the field and it is of shape quadrilateral and the diagonal of this field is 24 meter. So the diagonal is this is the diagonal. AC is the diagonal and it is of 24 meter length. And they have also mentioned that there are two perpendiculars from the remaining two vertices. Remaining two vertices are B and D. Why? A and C. This will become the diagonal. So the remaining two vertices are B and D. They are saying that there are two perpendiculars from this remaining two vertices and it is of length 13 meter and 8 meters. So we have to find the area of the field. Okay, so diagonal is equal to 24 meter and the perpendicular height is 13 meter and H2 is 8 meter. We need to find the area. So how to find this? Consider this figure. What I have done here is I have break this figure, okay, I have split this figure into two parts. Okay, this is one triangle and this is another triangle. So if we find the areas of this individual triangles and add the areas of these two triangles, we will get the area of quadrilateral, right? So I'll explain in this figure also. I have split this figure into two parts. This is one triangle and this will be another triangle. If we find the areas of these two triangles individually and add the areas of these two triangles, we will get the area of this complete quadrilateral. Okay, let's do it step by step. Okay, I'll write it here in the next slide. Area of quadrilateral. Quadrilateral A, B, C, D. Will be equal to area of this triangle plus area of this triangle. Okay. Area of triangle ABC plus area of triangle ACD. Right. So first let us find the area of triangle ABC. What is the formula to find the area of triangle? That is half into base into height. Do we know the values of base and height? Let's check. Okay, this is the base of this triangle and this will be the height. Have they given the values? Yes. they have given AC is the diagonal and it is of length 24 meter. So this is 24 meter. So AC, both the ACs will be 24 meter. And the height from this point to this, I'll mark it as O. Okay. And the height, they have given it as 13 meters. Okay, we got the values of both base and height. Let's substitute it. Half into base is 24 and height is 13. 2 ones are 2, 12s are 24. So, 12 into 13. 3 2s are 6. 3 ones are 3. 1 2s are 2 and 1 ones are 1. So 6, 3 plus 2 is 5 and 1. So the area of triangle ABC is 156 meter square. Right. So now let's go ahead. Let's find the area of triangle, the next triangle. What is it? Area of triangle ACD. Area of triangle ACD. The same formula holds good to find the area of triangle. So that is half into base into height, right? So half. Do we know the values of base and height? Let's check this in this figure. So base is nothing but AC, that is 24 meter, and the height D, I'll take it as E. Okay. Have they given? Yes, they have. That is 8 meters. Okay, we know the value of base, that is 24, and the height of this triangle is 8 meter. Let's substitute. Base is 24 and the height is 8. 2 ones are 2, 12s are. What is 12 into 8? 8 twos are 16. 8 ones are 8 plus 1, 9. So 96 meter square. Now we got to know the area of triangle ABC and area of triangle ACD. If we substitute these two values and add, we will get the area of quadrilateral ABCD. Right? Let's substitute the values. So, area of quadrilateral ABCD is equal to, what is area of triangle ABC? That is 156 meters square. 156 plus, what is area of triangle ACD? It is 96. So, 96. If we add these two, we will get 252 meter square. This is nothing but the area of quadrilateral ABCD. I hope you have understood this problem. Let's look into the next one. Let's look into the problem. The diagonals of a rhombus are 7.5 cm and 12 cm. Find its area. Here, they have given that there is a rhombus. And the diagonals of rhombus are 7.5 cm and 12 cm. We need to find the area. This is very simple problem. Just we need to know the area of rhombus. Okay. So what is the formula to find the area of rhombus? That is half into diagonal 1 into diagonal 2. We know all the values, right? Diagonal 1 is 7.5 centimeter and diagonal 2 is 12 centimeter. If we substitute, we'll get the answer. So, diagonal 1 is 7.5 and diagonal 2 is 12. So, 2 ones are 2 6 are 12. So, 7.5 into 6. Okay. What is 6 5s are? 30. 6 7s are 42. 42 plus 3 is 45. So, since there is only one decimal point after a digit, we need to place that after one digit here also. It will be 45 centimeter square. So, the area of rhombus is 45 centimeter square. Let's go ahead with the next problem. Let's look into the problem. Find the area of a rhombus whose side is 6 centimeter and whose altitude is 4 centimeter. If one of the diagonals is 8 centimeter long, find the length of the other diagonal. They have mentioned that there is a rhombus. I have taken this figure and its side is 6 centimeter. The side is 6 centimeter and altitude. Altitude is nothing but the height. So, the height is 4 centimeter. Okay, this is 4 centimeter and one of its diagonal is 8 centimeter. These are diagonals and one diagonal is of length 8 centimeter. Okay, we need to find the area and the length of the other diagonal. Okay, so I'll repeat here. We need to find the length of one diagonal, other diagonal, this diagonal, and area of the rhombus. We need to find the area. So, we need to find the area and length of diagonal. Okay. So, before solving this problem, I want you to know that rhombus is parallelogram. All properties of parallelogram holds good with rhombus. So, by using the formula to find the area of parallelogram, we can find the area of rhombus. As I mentioned, area of parallelogram is equal to area of rhombus in this case, okay? So, why we are doing this? Because area of parallelogram, what is the formula to find the area of parallelogram? That is base into height. Here we know the base as 6 centimeter and the height as 4 centimeter. So by doing this, we can easily find the area of parallelogram, which is nothing but the area of rhombus. Okay. So area of parallelogram is equal to base into height. Okay, I'll do in the next slide. So, area of parallelogram is equal to base into height. So, what are the values of base? Base is 6 centimeter and height is 4 centimeter. So, base is 6 and height is 4. What are 6 4s are? 6 4s is 24. So, the area of rhombus is equal to 24 centimeter square. I'll write it. Please don't be confused, okay? Since rhombus is a parallelogram, all the properties of parallelogram holds good with rhombus also. So the area of parallelogram, by using the formula of area of parallelogram, we can find the area of rhombus. Have done the same thing here. So area of rhombus is equal to 24 centimeter square. Okay, now let's find the length of the diagonal. This can be easily done. We know the formula to find the area of rhombus, that is area of rhombus is equal to half into diagonal 1 into diagonal 2. Right. So, we got to know the area of rhombus is 24 centimeters square, and we already knew the length of diagonal 1, that is 8 centimeter. If we substitute this value, we will get the value of the other diagonal. Let's do it. So, area of rhombus is equal to half into diagonal 1 into diagonal 2. What is area of rhombus? That is 24 centimeter square, and half into 8 centimeter, and diagonal 2 we need to find out. So 2 ones are 2 fours are 8. So 24 is equal to 4 into diagonal 2. So diagonal 2 will be equal to 24 by 4, which will be equal to 6 centimeter. So the length of diagonal 2 is 6 centimeter. I hope you have understood today's session. Let's continue with the next set of problems in the upcoming session. So until then, stay home, stay safe, take care, and bye-bye.